let's practice writing the full and noble gas electron configurations for strontium. Strontium is element 38, and it is outlined in blue on the periodic table. So just looking at the periodic table itself, the leftmost two columns make up the S block. The right-hand side of the periodic table, except for helium, make up the P block. These elements, mostly drawn in purple, are the D block, which are primarily transition metals. And then down at the bottom, we have the F block. So for strontium, we're going to start where we always do, in energy level 1, which is the first row of the periodic table. We can write this as 1s2. That includes hydrogen and helium. Moving on to energy level 2, which is the second row of the periodic table, we have a full electron shell, so we can write 2s2, 2p6. Moving on to the third row of the periodic table, we have another full shell with 3s2, 3p6. And then moving on to the fourth row is where it gets a little interesting. So we have our 4s2 as labeled, and then we get into our D block. The D block is lower in energy than the S block, so we're going to move down to energy level 3 for 3d10. Then we can continue on with our P's for 4p6. Now our element is located in row 5 of the periodic table, and we have 2 electrons to get us there, so we have 5s2. So that is the full electron configuration. But what if we wanted to do the noble gas configuration? So for the noble gas, I'm going to highlight the previous noble gas that is closest to strontium. In this case, it is krypton. So for krypton, we put krypton in brackets, so Kr, and then that eliminates everything highlighted in green. So by condensing this into the noble gas configuration, we can get rid of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and all we have to write is 5s2.